Okay, this is a basic tutorial on how I've got the Arduino to work. Yes, I'm building a Internet of Things speaker. I'm slowly working towards it. And just for people listening, I've just recently learnt how to arrange the little microphone here. So we type in the command here, Arduino. We click on that, and this is the app which will operate the boards from inside. You can go on the web, or you can download a non-web app. It's perhaps best to download a non-web app rather than relying on web storage. It's preparing boards, taking a little bit of time to do so. So Arduino is a 1990s technology, and they've gone up, and I'll want to open a recent file which is read times 3 load cells. So I'll show you how it goes. I expand this up. So this is an overall file, and I'm running this board here, little Adafruit feather board. It's about a fifth the size of a credit card. Gone from reasonably high upload speed. The CPU there, it's got 4 megabytes in memory. I don't know exactly what SPIFs is, and it's got various things here, and so I suppose the important thing to see is it's port COM5. It's out of it. And what we'll do here is we'll expand this up here so you can see what it does. And we're going to here is to upload it to a board. So on a USB, I've got the little board which I've written previously there. Now I've had a hell of a time just recently with the board jamming, and what I'd done is inadvertently miscounted the number of port numbers, and I had hooked up a temperature sensor into the communication USB port. Of course, the would read the temperature and jam the device. So this is just picking up all different libraries that it's used. Coming up here, you might speed this up a little bit as we come along, and just keep on doing it. So maybe in an infinite loop now of going through. I know here it's generating function prototypes, compiling the sketch. You can read it yourself. This is the temperature sensor. I don't know what the EEPROM is. SPI is also something necessary to be used. The Wi-Fi I'm not using, but I want to put it on Wi-Fi. So the actual little chip has a web server in it, and it also has a web page inside it, so you can just pick to the URL. So it's having a little bit of a think about it. So this is the dreadfully slow part, so this must be enormously slow. So it's picking things up at whatever hash is, I don't know, and then it's going to the core. So there's a huge number of libraries just going in. It seems enormously slow, say, compared to LabVIEW. So it's sort of like the poor man's version of LabVIEW going in. So this, if you can believe the number of packages coming out of here, is quite impressive, or quite an amazing thing to see. But this is a live one, so it's the Adafruit. So Lady Ada is this fantastic female entrepreneur who manages to get chips built. That just, well, it's not, you don't have chips anymore. We had before, you used to buy chips. Now you buy a little board with a chip on it, and then you solder into it, and the board's got the resistors and various things in it. So this looks as though it's coming towards the end here. Now it's beginning to upload it to the board. Now when it uploads it to the board, these dots are the dot, and the actual board itself is glimmering a little blue light when this happens. Okay, at this point, it's, you know, what is going on in this modern age of computing? But this is a step up from the Arduino boards. This is a sort of a board which is sort of 10, 20 years out of date as far as I can see. So this is, it's up and running, and the board is blinking. Now what I'm going to do is I'm going to call a serial monitor, and you can see it's here. It's reading the various load cells. So I have 3 load cells which are going to sit under the feet of each tripod of the Bunsen burner. Now this particular load cell I'm going to press here, you can see in L2 it's increasing, and then I'll just press another one here, and that's L3, and this will be L1, and then this is the temperature of the chip. I still haven't quite worked out how I'll use this, and I'm going to put the thermocouple in my mouth, so it should go up to around 36 degrees. So that's all fairly simple. So let's just look at the code which does it. So this is the code coming on. So what I'll do is I'll reduce this a little bit so you can see it. Okay, and just bring this down here. That's the compiling. So I've basically this is the load cells. The HX711 is an A to D preamplifier, so it as an A to D converter, it sits directly underneath your load cell, and so you no longer send analog signals over a long distance. And then these are the libraries down here that you have to include, and I've had an unsuccessful attempt to publish this to the web page. I've got different load cells, and these are the pins that the load cells go on, load cell 1, 2 and 3. Then this crosses across to the 3 pins for the temperature sensor. There is this way of having a temperature sensor which only goes on one wire. I haven't quite worked that out yet. Again, we'll just go through here. I've commented on a lot of things which haven't worked so far. Now the problem is that they haven't worked because I had this sort of various other problems going on, so I couldn't work out whether it was the wireless doing it up. Then you begin your serial, saying your serial producing serial print line. I don't know why it just wants to print a line. Then it says starting, and then it's got load cell 1, 2 and 3. Now what we'll do is we'll just I don't know, get rid of auto scroll here, and just here we go right up to the top. Oh, I think I've missed that section there, but it does, if it starts up, it does show you all this type of stuff. So it gets the load cell. I don't know what this has a stabilizing time. Again, I do not quite understand what this is here for. Now this is the thermocouple. Thermocouple's coming on. I decided to put Wi-Fi. I've got to reduce that. Oh yes, I've commented out that's for the server here. This is the load cell with the 3 load cells. Look, I really don't quite understand how this particular thing works. It seems to be modifying it. Then it says print, and it prints the chip temperature, thermocouple read, and at the end of here you've got this line feed in there, and that's almost about it. I just got to read. These are basic things to tear it, so that's how it works. And we come up here and we do auto scroll again, and it's continuously updating. So that's the temperature. I'm going to touch the temperature here. My hand's touching it, so you can see the temperature increase here, and your various load cells. And the idea is that I'm going to have a look at this. So the load cell, if I put something as a small little washer on one of the load cells, let's see which load cell I'm going to be using. So it's load cell number 3 to watch. It stabilizes at -15. So one has to work out what that's doing. So I've put one washer on it. It's gone up to -14. These are tiny washers on it. I don't quite know. That's. Oh, yeah, you can see each washer is like a fraction of a gram, and so you can see the sort of sensitivity you're going to get out of that. Now it's the entire thing is stabilizing it. I don't know if you watch along here, every once in a blue moon it drops out. There you go, 16.25. So I'll have something in software to try and pick it. See, that's 16 there. That's an incorrect measurement. So I should be able to improve on that. See that 15.5 coming along here. And with this here, they drift over time. So I've got to work out a way of doing it to make it higher accuracy. So not only having your beaker, your school beaker live, I'm going to have to see if I can get the temperature sense reading to 0.1 of a degree. I'll see if I can get there, and the mass reading much higher than is normally possible. Thanks a lot for listening.